Audio Jungle.
Hello everyone, welcome to the video lecture series of operating system. In today's session, we are going to continue with the topic input-output management and disk scheduling. Specifically, we are continue with the topic input-output management in this particular session. Myself, Kunal Panchal, your instructor. In this particular session, we are going to discuss the concept of direct memory access, or we can say DMA. DMA stands for direct memory access. So what is the significance of direct memory access and what it means actually? So before going to directly jump into the direct memory access, let us discuss first what is the requirement and what was the problem in early era when we do not have this concept direct memory access in computer system. So what was the problem? Let us discuss that problem first. So in early era, what will happen in the case of early era? Like suppose any input output device wants to communicate with memory module in computer system. So input output device is nothing but peripheral devices. So you can see in this particular figure there are three main blocks. One is input output device, second one is memory, and third one is CPU. So in first of all we are talking about the problem. Okay. So in early era, input-output device wants to communicate with memory, or memory wants to communicate with input-output devices. So what was happen in that case? Suppose say for example input-output device wants to transfer some data or store some data into memory. Okay, so that input-output device first of all send the data to the CPU, and CPU will send or transfer that data to a memory. So it means what? This operation requires two cycles. One cycle is required to transfer the data from input output devices to CPU, and another cycle is required to transfer data from CPU to memory. Means each cycle, and you know very well, each cycle contains three main phases. One is fetch, second one is decode, and third one is execute. Fine. So these operation, a single operation requires two cycles to complete. Yes. So it means what? That is it is somewhat time consuming approach, because as far as input output devices and memory, if you are comparing CPU and memory, both are digital devices, and they are very fast. As compared to input output devices, because input output devices are not digital devices. Fine. So it is very slow as compared to the CPU and memory. So what will happen? These operation takes a lot of time and a lot of computation power. So it is time consuming approach. Fine. So if you want to avoid this problem, what we can do is we can introduce one concept called direct memory access in this particular figure. So what will happen when direct memory access come into the picture in this particular figure? So when input output devices wants to communicate or store some data to memory. Okay, so in this particular case, what will happen, instead of contacting to a CPU and CPU will contact to memory, in this case, if you are using direct memory access concept, so CPU input output devices can directly communicate with memory without the intervention or interruption of CPU, or without involvement of CPU. If these two devices, IO devices and CPU, so memory, wants to communicate with each other, that is possible with the help of direct memory access. So how it is possible? Now let us discuss the significance of DMA and how this operation can be performed, through which IO devices can directly communicate with memory. Okay, so you can see in this case, the IO devices, if IO devices can directly communicate with memory, so this operation requires only one cycle instead of two. So definitely this operation is somewhat faster as compared to the previous case. Fine. So let us discuss how DMA will play an important role to increase the speed of execution for transferring the data, or to store the data into the memory or from the memory to IO devices. So let us discuss the working of DMA, or operations of direct memory access with the help of one figure. So before going to discuss the working of direct memory access, as I told you in the previous session, as I told you in the previous slide, a spatial control unit may be provided. A spatial control unit, which is nothing but direct memory access, may be provided to allow transfer of a block of data directly between an external device. External device means what? In this case, it is nothing but peripheral, or input output device and main memory without continuous intervention by the processor. Intervention of processor is required, that we will see in the next slide. Definitely at initial stage the intervention of CPU is required, but the continuous intervention is not required. Fine. So that we can utilize the CPU for other computations, because CPU is, as I told you, it is digital device and it is very fast, and it is basically, it is intended to do some high computations. Okay, so if you are using processor as a CPU for transferring the data from one device to another device, definitely you are not utilizing the power of CPU in an efficient way. Fine. So we don't want to involve processor in data transfer. That is the main concept of direct memory access. So this approach is known as direct memory access. Which approach? A spatial control unit may be provided to allow transfer of a block of data directly between an external device, or input output device and main memory without continuous intervention of the processor or CPU. This approach is called direct memory access. So let us discuss that approach. So in this particular figure, you can see this is the figure through which you can understand the working of direct memory access unit. So DMA is one type of, you can say, controller we have, and controller is nothing but special purpose processor, or a special processor we have. CPU is nothing but general purpose processor, but DMA controller, when we are talking about controller, it is designed to do some specific task only. So that is the reason why the controller is called as special purpose processor. That things you have to keep in your mind, the difference between processor and controller. Okay, let us discuss this figure through which we need to understand the working of DMA. So in this particular figure, you can see there are four main blocks. One is CPU, second one is DMA controller, third one is disk controller, and fourth one is main memory. Okay, so these four blocks we have, and these four blocks are connected with the bus, okay, for communication purpose, for data transmission. Okay, so all these four blocks are connected with bus. Okay, now what will happen in this case? You can see there is one drive, or you can say secondary memory we have in this particular figure. So that we called as input output devices. Okay, so let us start with the working of DMA. So first of all, what will happen? As I told you, at initial moment, the intervention of CPU is required. So what CPU will do first? So CPU will very first, you can see very first step, CPU will do what thing? So CPU programs the DMA controller and sets the value of the different registers that it has. Okay, so what CPU will do? CPU will program the DMA controller and it sets the value of the different registers that we have in DMA controller. So one is address, second one is count register, and third one is control signal. Means what? Whether you want to perform read operation or write operation. So that is nothing but it indicates which control signal indicates which type of operation you want to perform, whether you want to read something or write something. Okay, count means what? I will tell you later on. So count register will store the byte count, and this count value would be decremented once the one cycle is completed. Means what? One block of data is successfully transferred to the memory. In that case, this count would be reduced by 1. How? Let us discuss. So this is the first operation, or first step we can say. CPU programs DMA controller and it sets the value of the different registers in DMA. Now one more thing CPU will do. CPU now tell to the disk controller. Okay, CPU will tell the disk controller to read the data from the drive and store into a buffer. So what is buffer? What is significance of buffer? Buffer is basically used for temporary storage. Fine. So what CPU tells to the disk controller? So CPU tells the disk controller to read the data from the drive and store into the buffer. Why we are storing that data into a buffer? Because if data is not stored in buffer, the DMA controller cannot access that data for transfer. So it means what? DMA controller can perform its operation when the data in disk controller stored in a buffer only. Okay, so once the data is stored, now the next step is what? Now DMA controller. Now DMA controller will come into the picture, and DMA controller request the disk controller to transfer the data from disk controller to the main memory. Means what? It will request to the disk controller by accessing this buffer which contains the data which is stored, which is read from the drive. Okay, so that data needs to be transferred to the main memory. Yes, so these requests would be initiated by the DMA controller. Okay, now once this request is received by the disk controller, now what disk controller will do? Disk controller will simply fetch the data from the buffer, and buffer is nothing but buffer would be data would be stored in the case of buffer and fetch from the buffer in first in first out manner, FIFO. Okay, first in first out manner. So it will be fetched from the buffer, and this controller will transfer the data to the main memory. Okay, once it transfers the data to the main memory, what this controller will do? in the fourth step, this controller will send the acknowledgement signal to the DMA controller, so that DMA controller will check the value of count register if byte count is equal to 0 or not. So if the byte count is equal to 0, in that case what it means, the data transmission is completed successfully. Yes, whatever the data we want to transfer from the disk to the main memory, or case input output device to the main memory, that is completed. So if count register value is 0, it means what? Transmission is completed. Now what will happen, once the value is 0, the DMA controller will generate an interrupt signal and send it to the CPU to indicate that the transmission is completed successfully. But what will happen if this byte count value is not 0? It means what? Still we need to have some data that we need to transfer from the IO devices or a secondary memory to a main memory. So what will happen in this case? So again, the step number 2, again DMA controller will request to the disk controller to fetch data from the buffer and send it to the main memory, and then it will send the acknowledgement once again to the disk controller. Means what? This step number 2, step number 3 and step number 4 will be repeated until the byte count in DMA controller is 0. Okay, so these things you have to keep in your mind. So in this way, direct memory access works. So you can see in this case, at initial level, the involvement of CPU is required at initial stage. Once the data transfer is started, okay, and once it is completed, then and then, if you want to start another block of data transfer, in that case again CPU will come into the picture, so that we can reduce the involvement of CPU in this data transfer. So definitely it is less time consuming, it requires less computational power, so this data transfer would be efficient in this case with the help of DMA controller. Okay, so this is the main idea about direct memory access, through which we can reduce the execution time specifically for transferring a data from input output devices to memory or main memory to input output devices. So I hope it was clear to you. Thanks for watching this video. See you in the next one.